Good afternoon, everyone. Welcome to the webinar arranged by Desapex. So this is our second webinar which we are having in this series of webinar which we will be doing related to digital technologies with respect to the built environment. So the last session we had conducted on the digital twin solutions which we have partnered with one of Finnish company. So in this session we will be talking about BIM-to-Field, how we can bring the models back to the construction sites. So today with me, my colleague Abhay and our technology partner from Altera, Mr. Adesh, will be sharing their means information related to how we can take these models back to the site. So we will wait for a couple of minutes. So the attendees are joining in, and once we get the go ahead from the team, we can actually continue with our session. So yes, team, we'll start today's webinar. Just to introduce about what Desapex does and what are our capabilities. So the mission of our organization is to actually enable digital adoption and integration of technology for target value design. So in the built environment, so we want to integrate the technology in terms of software and hardware and bringing in the target value design for our clients and customers. And by doing this, we have a vision of bringing a sustainable built environment. So these are some of the project officers and also the offices which we operate from. So we are serving pan India and also having global customers base across the globe. And these are some of our segments which we are actually focusing on, and also the where we already have current clientele where we are providing these services. So this is a bit about our team. So I'm one of the partner of the organization, and also my colleague Srinidhi, who actually takes care of the engineering services. And our team consists of civil engineers, architects, mechanical engineers, and all blending in together with digital tools. So with respect to today's discussion, so we have a very interesting credentials which we have. So we'll come across in the next slides. And these are the services which we provide, that is digital project management. So you have decided that you want to do the project on BIM. So what are all the frameworks which you should be having to deliver the project on the BIM platform from the owner side? So if you are an owner and if you want to adopt BIM in the project, so what are all the frameworks which you should be doing in? And then digital design management is actually for the clients who are actually engaging with already with architects and consultants, and who want to convert their existing CAD traditional CAD drawings into the model and then perform the clash detection and coordination and different other analysis. So digital asset management is for clients who are actually already built the asset. They want to digitalize this property and then use it for operation, maintenance, and those kind of activities. So this is our approach. So we follow in the process, the standards which are available for the implementation of BIM in the project, and then definitely the tool knowledge. So we have to use different tools to do this digitalization. It is not only processes and frameworks, but we also have to understand what is the technology which is available, and of course the domain understanding. So whether you might be a civil engineer or a mechanical engineer, so you have to understand what is the how the building works and how it operates, how the building is getting constructed. So we have to know that. And with respect to today's discussion. So we are very proud to say that we were the first in the world to get an ISO 19650 certification, which is actually a global standard for BIM. And currently, we're the only organization in India where we have got this kite mark for BIM design and construction, and also for the operational stage where we are implementing these frameworks for digitalization. So this is our vision. So we want to branch out into different digitalization aspects, whether it might be BIM, Industry 4.0, smart cities, and then geospatial data adding on to that. So this is the type of digital network which we want to build in and provide services to our clients. So from here on, my colleague Abhay will be taking on to the session, and he will explain about what exactly is BIM to field and what is the use cases and what is the scenarios which he is able to deliver to the clients. Over to you, Abhay.
Thank you, Varun. Hello, everyone. This is Abhay Nayak. I am associated with Desapex as a digital design manager. So today I'll be explaining what is BIM-to-Field and how it is implemented in different phases of construction. For any project, some of the available information passed on to the project team might be old, and substantial changes might have developed after the document was created. Using such a document will mislead the project team and will impact the cost and time planned for the project. By capturing the accurate current conditions of the site, topography, or a core and shell of the building by using technology like laser scanning, enriching it with required information for upcoming phases of construction, and using the information-rich model for design, construction, operation, and maintenance out on site is BIM-to-Field. BIM-to-Field can be used in different ways for different stages of construction, from conceptual design to operation and maintenance and innovation. Let me run you through the different stages of construction and how BIM-to-Field is making a difference in the industry. Conceptual stage, which is the initial stage of construction, where majorly teams are working in silo. Bringing all this information to a collaborative platform can be fulfilled by using BIM. At a conceptual design stage, we offer services like technical due diligence and building limitation study. Technical due diligence is a systematic approach which will help our clients understand the condition of the building, analyze how well the building meets the standards and norms, prepare due infrastructure report for planning the costing of the project, and understand potential design issues. This also helps to make better scope matrix as it brings clarity about the work items. In a traditional method where the expert team visits the site and captures the information manually, there are higher chances of missing information, which will lead to confusion. The scanned data can be used and any information can be easily verified at any time. Few of the application of BIM-to-Field were in conceptual design stage are here. So integration of field data by laser scanning for plot or layout verification and precise programming. So like you can see in the image, there is a shuttering drawing where the beam is not being shown. The same was used for beam model development, and after the construction drawings were submitted, we found that the beam is casted at site. So this led to a major issue of chilled water piping with other services, and a major time and cost was lost. So in conceptual design stage, we can use it for preparation of fit-out guidelines and compliance check. To check the layout with respect to client fit-out guidelines and prepare compliance check reports like egress path, staircase adequacy check, etc., scan data can be very helpful. We can generate photo reports, layouts, and take the measurements for calculation. The same layout can be submitted for approval and authority. You can see an example which I have shown here in the presentation where egress path and the safe areas, unsafe areas are highlighted so that the client can plan better, and the non-occupiable spaces like washrooms and other areas can be taken to the unsafe zone, and he can redesign the entire layout. So it also helps in estimating right capex and opex cost with a detailed information of existing and new infrastructure. The scan data can be used to prepare a report on new infrastructure and feasibility check with placeholders for planning new installation. This will also help to achieve a higher accuracy in estimation of operational expenditure and capital expenditure costs. With the help of due diligence report, the handing over and taking over time can be analyzed precisely, as we know what is due and what is the lead time for procurement of the due infrastructure. The final verdict of the service will help our clients to decide to proceed with leasing or tendering, negotiation, or walk away from the project. So the next stage of construction is the detailed design stage. So in the detailed design stage, BIM can be used for visualization using technologies like virtual reality and augmented reality. At a very early stage, different design options can be plugged in for visualization, and the best suitable option. As at site, different stakeholders are working with their expertise. The process can be made collaborative using BIM, where all the stakeholders are notified with the changes made by others, and design challenges can be resolved in the design development stage itself. Overcoming constructability issues and clash analysis. While the design phase, various stakeholders are working parallelly in the discipline of their expertise. Major constructability issues can be resolved even before we hit the site. Services can be better coordinated using the BIM platform. In the image, you can see a HVAC duct misalignment because the plumbing contractor followed his own path and installed the pipes. Using BIM, the issue was resolved. Using BIM, the issue was resolved within hours, and detailed drawing was shared with the site team for execution. Once the design is finalized and GFC are submitted, we enter the construction phase of the project. In this phase, BIM is used for construction project monitoring. So in construction project monitoring, as you can see in the first image, real-time site progress is captured using 360 imaging technology. The same data is stitched with a floor plan and can be used for walkthrough from anywhere. We can also compare with the progress captured at a different site, different times side by side. Faster layout marking for verification and accuracy. BIM model can be used to mark sharp laser beams for marking points, which will increase the speed and accuracy of installation of services, supports, or marking of cutouts. As-built inspection by laser scanning. So as-built drawings, which are prepared using snag lists, might not be accurate to site conditions. FM team will face challenges to operate and monitor it if the real data is not captured. Laser scanning of the facility to update an as-built model using the model for operation and maintenance will be beneficial.
So thank you, Abhay. And I think now my colleague and partner Adesh will be taking in to explain about what are all the tools and technologies which we use to gather the data which Abhay has shown us now.
Good afternoon, everyone. So I hope you guys can see my screen right now. Just confirm me with a yes, Varun.
Yeah.
Is the screen visible? Yeah. Good afternoon, everyone. So as technology partners with Desapex, what we have learned over the past few months is that Desapex is basically having a vision of taking BIM to the next level. Now, when we say BIM, we need to understand the how, what, and why factor associated with BIM. So ideally, we have been doing historically a lot of work, but where are we tying all of this data together? Now, this is where Trimble as a solution provider comes into picture. And what we are doing along with Desapex is basically bringing this entire suite together, where we are talking about taking field to the, taking office to the field and bringing the field back to the office without actually missing data or without actually looking at the fact that I might not be as accurate as I wanted to be vis-a-vis my design. So what we will go through during this agenda is basically, I'll just touch upon what Trimble is. I will talk about how the solutions work around for Trimble. What BIM-to-Field basically would be what Abhay has very well explained a minute ago. We will talk about what solutions tie the entire BIM workflow together, starting from sensors, going towards the software aspect of it all, and also looking at how we go from AR, VR to MR, which is basically the mixed reality factor. What is HoloLens 2? Trimble basically was founded in 1947, and we have been into this industry for more than 4 decades now. Now, Trimble started as a GPS provider. So basically what Trimble did was build GPS engines. They started giving civilian access to GPS signals. But the company has grown from just being a sensor company to an IT company. So when I say IT, we are not talking just about sensors. What do we do with the data? Where do we take this data? So that is exactly what the workflow for Trimble or the road forward for Trimble has been. And this is exactly what we have been doing for all these 4 decades as to how do you bring all of this together, create solutions which are comprehensive in nature, and they don't take one from the other. We are not talking about just one ecosystem as per se. We are talking about taking data from multiple fractions, consuming it, and then executing them on the field. When we talk about construction per se, what do we do about construction? What is a construction process? The process basically means that I have a design, I have a plan, I have a design, I need to execute the design on field. The execution would mean that I need to know whether my execution is as per my design. And the 4th aspect is handover maintenance. The life cycle of the entire construction process is what Trimble is looking at. We are not just talking about sensors here. We are not just talking about software here. We are basically taking the life cycle of a construction process and making it more user-friendly, more comprehensive, more accurate. How are we talking about that? Starting right from the planning stage, where I can use multiple platforms. I'm not just talking about SketchUps. I'm talking about I'm not just talking about the Trimble products. We are talking about multiple factors, as I said. You can be planning, you can be designing it in Tekla. The Tekla design can be consumed within the construction stage of things, taking it to the design and engineering platform, go from fabrication to construction, and then at the end of it all, operate and manage. So when we say operate and manage, looking at the building, there is maintenance involved. I'm not just going to hand over a building, construct it, and hand it over. We're talking about a life cycle of the building. So when we have everything digitized, when we have digitization from the go, you are basically completing the cycle. You know exactly where, what, how, and how much is on that particular site. All of this simulation, all of this, what do you call, conjunction happens, 2D, making it all 3D, walking through these designs, making sure that the owner and the service provider are basically connected together, and the service provider is able to transfer this data to the owner in real time, and the owner is able to walk through that data and understand that, okay, whatever has been constructed is basically as per the design, and I know that there are no clashes. This entire exercise takes away the time factor. Initially, we were all doing this on the 2D platform. We were doing this historically using markers, using measuring tapes. Migration has happened from there on. We have accepted digital data sets, but digital data sets alone in the silo does not work. You need to connect it to a workflow. And the workflow is what Trimble is all about. How are we bringing that workflow together as technology partners? As I said, it's not just about one sensor, it's not just about one software, it's about how do you bring everything together, put it into a bundle, and produce the results that are required in order to actually have logical calculations to see if my timelines are being met, to see if all the material, my estimation is as per what is being actually consumed on the site. The portfolio, in our sense, sits on the 3D capture analysis, what Abhay was talking about. How do I do my field visualization? So field visualization is where you bring in the AR, VR factors together. and field layout. Now, when we bring all of this together, all this data at one point is on the site. How do I take it back to the office without actually going to the office? Is when we push all of this data onto the cloud. Now, cloud is what Trimble is basically talking about from the IT standpoint. When I say Internet of Things, what am I doing with this data? The data sets are heavy. There is a lot of work that has been done. There are delays in actually getting the results out and the reports out. I can create all of this now on the field. And when we say this can be created on the field, I'll just walk you through how this works around. So when we talk about the traditional workflow, as I already said, there are no 3D drawings. The site data is received as 2D. There are high possibilities of error, and there is no background model visibility. So I don't know whether I'm exactly going as per the model. I realized this later, that it is probably not as per the model, and we have to again redo the work. The updation of the progress takes more time, and the labor is heavier, concerned that you are doing something twice when you realize something is not right. This coordination is brought into effect right from the conception planning side of things. So controllers, which Desapex owns right now and which we are talking about, is taking this data onto the field now. So I can actually take my entire IFC file right into the field. I go into the field, do my layout as per the design. I can create points on the field. I can create points in the office. I can actually mark the points which are existing in the design or create new points on the field as well, where I know that the clashes might happen. The report is generated in the end of the day, and this report is pushed to the cloud. And you sitting in the office somewhere on the other shore of the sites can actually access all of this using the data which is already being pushed to the cloud while in real time. The entire cycle, as I said, is not dependent on one CAD platform. It can come from multiple CAD platforms. We are talking about everything that is available, from Bentleys to Autodesk to Revits. Everything is basically taken care of. How is the workflow working towards? So I will just go through this video, but I will not go through the entire video. What I will do is I will keep talking about this. So when we say BIM-to-Field, first is the office data preparation. Now this is again conditional. I can actually prepare the data in the office, create my points. So I can take the support family points and I can then go out and lay these points out in the field, or I can actually do this even in the field while I am with the instrument right there, because the design is sitting right on my controller. I have actually taken the design to the field. Instead of basically taking these files in 2D and then going to the field and then laying them out, what you are doing is you're going a step further. You're taking this design, calculating laying out the points, and these can be hundreds and thousands of points that you need to lay out. Doesn't matter, because the controllers and the logic behind the algorithms on the softwares, that is Trimble Field Link, can handle huge sets of data. So it is basically free for data for data capacity. You can be laying out. We have done around more than 1,000 points, 2,000 points in there. So when we say 800, 600, this is what the point layout time for you typically can be. And you are done with taking this onto the field, and now you are laying these points out onto the side. You are basically, what you are doing is you're saving that time out. Now, when we say save the time out from exporting the data, not being accurate enough, the total station is taking this, consuming this design from the controller, and the total station or the robotic total station basically leaves this green laser out, which is precise to 2 mm or less. And this particular precision is achieved while I want to do my MEP layouts, say for example, my hangers. Now my guy has to basically, while we all know the pain that the hanger layout basically is. Now with the green laser, my guy simply goes up, marks the point in, and comes out. So this is how fast the layout can happen. I can then create my day's report, and I can send this to the owner to know how much work has actually been done onto that particular floor, how many hours did the guy work, and what kind of data did he basically come out with. All of this goes back to the office. Now again, as I said, it's all pushed to the cloud. This is how a layout summary would look like. The daily layout report, deviation, if there are any from the design, are very well demonstrated. So you see there is DH and DV. So that is your deviation horizontal and the deviation vertical. What accuracies are you maintaining in order from the design to the field aspect? What is my surface report and the field report from from the robotic total station or a laser scanner that is X7 will come into, and this all report is similar, the entire workflow. So the application that basically works on the field is called Trimble Field Link. It works on the robotic total stations. It also works on the laser scanners. Moving on from here, where we go is basically talking about how the scanning system works. We have basically the webinar is, but I wanted you to have a comprehensive look of how Trimble basically sits on the solution side of things. When we talk about scanning, this is what you are looking at. This is an X7, which comes with 500,000 points per second. It has 5 onboard cameras, 10 megapixels each for imaging. So you are basically creating photogrammetric evidence as well as point clouds. And it is all self-leveling. It has a collimator inside, first of its kind. It balances itself even at even at angles at 45 degrees. So there is no learning curve in order to operate a laser scanner like X7. What does it do within the construction phase? Now, within this construction industry, the major issue I have is basically I don't have eyes. There's no magic happening where I can fuse the point cloud that comes, which is a very heavy file, to my model. What you do with the field link application, which is again independent of the laser scanner or the robotic total station, it's the same application. It helps you consume this point cloud. It helps you to bring the design out, and you can actually have the scan to BIM aspect addressed here. So here what you see on this particular image is that it is laying the point cloud onto my design. So I know where my surfaces are, how flat is the surface, whether it is as per the design or not, am I deviating, how much am I deviating? All those reports are created right there in the field. When you walk through this particular video, you can see how the laser scanner basically can be set up. As I said, it's a one-man operation. Nothing is complicated about this. There's no learning curve for non-surveyors, because there is this particular notion that, okay, if there is a total station, if we are talking about laser scanners, you need particular expertise in order to work around with them. No, I think Varun and team can very well validate that anybody can use this. They have been using it for sure, and they are experts on what they do. So once I create this particular data set using the laser scanners, I can basically have automatic registration happening right there in the field for multiple positions that I take on a typical floor. Once that is done, I bring in my model. I bring in my model onto the point cloud. I lay it over, and I see where my particular as-built is looking like on my design. So this is where you bring in, the complete station view. Now, this is all happening in real time on the field. So what you are doing, you're basically generating a viewer account of how my data looks like, generating your multiple measurements. You can actually store them with imagery. You can have your point cloud in grayscale. You can have your panoramas created. All of this can be pushed back to the owner or to the contractor, or even as a service provider like Desapex. What they would do is that they can send this data in real time to you without wasting any time. You know, during at the end of the day, this is what I'm going to get. This is what is happening on my site right now. This is what has been constructed. Are there any clashes from the design? Is my design perfect? Is my as-built perfect? Moving on from the station calculations, I can also actually have my perspective views. Now, when I say perspective, what am I doing is I'm overlaying. So this is something that Abhay was talking about a minute ago when he was talking about bringing the design, bringing the point cloud, overlaying it on the model. Now, this is where I actually have my review of the design to the as-built, where I know that, okay, there was a particular duct going through here within my design. Is the duct constructed as per the design or not? I can overlay the design onto the point cloud. And these are my reviews that I do right there onto the model data. So you have your QA, QC done right in the field. Now, if during the whole process, during the day, if Desapex, for example, is working on your project and you realize that, okay, I need a particular slice of a section of the building or a floor that needs to come back to me, and I want to review what is happening there, we can actually export this data in real time. Only the slice that you require, say, for example, a room or a floor or a section of the floor, and you can send this data for review back to the office. Now, again, what we are talking about here is not just the point cloud, not just the sensor which is capturing the point cloud data. We are talking about the software, which is actually allowing you to bring in the model onto the field. And then we are talking about the process where you're taking this back to the office, without losing time. So that's where the ROI basically stands at. When I say it is independent of any third-party CAD program, so we are not looking at binding anybody onto a one ecosystem. CAD platforms. Your design can be synced. So for example, Desapex is using Autodesk. You are a Bentley user, or you are a Revit user, or a SketchUp user. The platform gives you the ability, it is open to consume data from any of these third-party softwares. Desapex is equipped to do that right now. So they can take this data from you in any particular format that you are working. So you are not changing your ecosystem. Desapex is not changing their ecosystem. We are basically bringing in a homogeneous approach to have you sit within your ecosystem, they sit within their ecosystem, and the data is still flowing from one to the other. So the channel of communication is opened up where we can consume data from any third-party platform. You have Navisworks. I can send this data back to you and your team can do the clash detections. I can share this data through connected platforms from the field. So Trimble Connect is what the cloud platform is all about. And Trimble Connect access is free for all. So the only licenses required is to publish, and the service provider already owns those licenses, so they can publish this data for you, and you at your own end as owners or contractors can basically look at the data the way it is using Trimble Connect, download it, view it. The third aspect, so we moved on from the robotic total stations to laser scanning. Now, third aspect of the workflow is basically where you bring all of this onto a more virtual platform. When I say onto a more virtual platform is how do you bring and move from the virtual reality to augmented reality to another thing, which is called mixed reality for construction. So what are we talking about when we say mixed reality for construction? You have VR, which is primarily indoors. You have AR, augmented reality, which is primarily outdoors. But how do I fuse these two together? So what Abhay shared was Sight Vision, which was basically an AR equipment. You have an outdoor, you have your design, you want to see how my design sits on the field. So I have a complete factory design. Now I have a greenfield project, there's nothing built there. I want to see how the factory looks onto the field. I have that AR capability using Sight Vision. I can actually see where my clashes are happening. If in case I need to raise something, I need to dig something, I know where to do that. VR is where I am more indoors, where I'm looking at more indoor furniture. There's a typical floor, where would the columns go, where would the furniture go, where would the office be, where would the door be, where the lift would be. So all of that is basically VR. We are talking about something called mix. We are bringing both of them together as a solution. And we are looking at indoor and outdoor best case scenarios. Now, when I say indoor and outdoor best case scenarios, we are in 1997, this was basically done by Trimble way back, but then it was still a hard hat. It was pretty heavy in equipment and they needed to redesign. So 1997 is when we patented this entire exercise of having the VR stuff come to us. In 2019, Trimble basically hugged on. So we are talking about 20 years of innovation onto the whole thing, and they come out with HoloLens 2. Now, what does HoloLens 2 with Trimble Connect do is that all your data is sitting on Trimble Connect. As I said, it's a it's a cloud platform, and I can consume that data from the cloud using this HoloLens. And where all do I go using this? So an architect can use this. So we are talking about Sight Vision for architects, so something that was the VR aspect of things. Then we have the general contractors using it for coordination. Then we have prefab guys, so prefabrication guys who can actually have and know how the design sets and how the fabrication happens. Are there any bends or is there any deviation? Then we have the subcontractors who are basically looking at remote assistance and 3D task management to install for installations. And then we have the maintenance staff who know what, where, and how are things laid out onto the actual floor. This is where the whole connection, now I'm talking about how life comes a full circle, is that you started from laying out, you went on to creating the as-built, and now we are talking about moving in to the virtual world. When we move into the virtual world, this is what you look like when a site is being done. So this is an actual site video where you have the design put in. So this is where the shaft of the lift or the door to the staircase. So you basically open this, you look at this, the design is sitting onto the actual site. So the site is right there. I've brought in the design and I'm checking how my entire floor work looks like from here. is everything as per. So the columns are built, are my columns as per the design. So you can see this, the design is sitting right there onto the as built. And if there are any deviations, what kind of deviations are we talking about? The measurements are possible. Every point is measured here. So we are into the mixed reality world of things right now. When I say measurements and are things working the way they are, you are then taking this the outdoor side of things. So we are talking about the outdoor as built. Now from the outdoor as built, I can actually move into the indoor world of things and see where my clashes are from the typical floor perspective. So here, the next video is the indoor video where I have a typical floor. I have an office space. I want to see how my furniture looks like, how my layout looks like onto the floor. Where do I put my furniture in the right way? So I have designed something. My architect has designed that this is how your layout should be. This is how your tables need to be, how the cabins would look like, how many chairs into a conference room, what kind of table in the conference room. Everything has been measured and designed for. But how do I move on from there and see how it actually sits onto the site? This is how you are basically bringing the mixed reality world into an existing floor space. So now I know exactly what are the dimensions, how does the glass door look like, how the cabin is worked out to be, what size of table is actually working out within the cabin, what kind of space is left when I'm moving around. So when we do this exercise, this is where the whole mixed reality function gives value to something that needs to be done later on. You realize certain things are not right, and then you realize that, okay, I need to redesign this or I need to change the furniture. You actually are basically taking this and doing this right there while the construction phase is in place. When we talk about BIM, this is exactly what we're talking about. How do you bring everything together? How do you tie these small little pieces which are being done by multiple other different contractors, and then you realize, okay, something here does not fit, something there does not fit, timelines are being compromised just because we don't coordinate the way it is supposed to be coordinated. When we say coordination, this is what coordination is all about. How I bring all of this together, how I tell my contractor this is what is required, how the fabrication guy knows, okay, am I following the design or not, how my maintenance staff knows where and what is lying in the silos. This innovation of the mixed reality factor is basically going on. We are innovating every month. We are innovating every quarter. We are innovating every 6 months. Something new comes up. Currently, with whatever is available, with all the innovation that has happened over the past 2 decades, we are talking about these particular tasks that we can address today using mixed reality. I can have my design reviews. I can have my pre-construction visualization done. I have my clash detection coordination. I can do my guided assembly training. So training is another part of it where we are basically using a lot of mixed reality things for police, for forensics. I work heavily into the public safety space as well. How are we going about training them about fire hazards, how a fire site looks like, what they do. So we create these mixed reality simulations for them, and they walk through that. They are getting trained on the same thing. Same is for safety. Then we have these 3D task management for using the mixed reality function, and also the QC, which is the most important aspect of the entire workflow. So when we say BIM, again, we are not just talking about sensors. We are talking about how this entirely fits together. How do you turn these small little pieces and create a pie out of it? So everything that we spoke about right now is just a piece of the pie. But when you bring all of this together, you have a 10-inch pizza to you. So that's what BIM, 3D reality, solution point of view. That is what Desapex is heading towards, and that's where we have partnered. So I'm very confident that Varun and team basically are looking at something that I haven't seen much into the Indian market scenario, where, and I've been doing this for the past 15 years now, where I have been going on, talking about BIM, talking about digital reality, creating the as-builts. Now I see that there are service providers who have started realizing the fact that it's not just about getting a project, finishing it. It's about how do you basically complete the cycle. So that's about me. I think Abhay can basically take over and talk about. So I will stop sharing here, Abhay.
Yeah, thank you, Adesh. Thank you for your insightful presentation about how
Thank
we
you so
can
much.
take the models onto the site,
Yes.
and how we can bring site to office. So now what Abhay will do is he will talk a little bit about or share our experience about how once the construction is done, so what are all the things we will be bringing in as from the model, and how finally an owner can use this model. So the ROI does not stop on the construction, does not is limited to design, but how these models can be brought back even for an already existing facility using reality capture and different other techniques for facility management and maintenance. Over to you, Abhay.
Thank you, Varun. Last and the longest phase of any project is operations and maintenance. Simplifying this process will support owners for easy maintenance of the building. Having all the data in one format actually reduces the duplication of data and confusions. All the teams can refer one single format of data, which will reduce a lot of confusion. By asset labeling the components in the BIM model, we can effectively locate the equipment at the site, and all the data fed into the element can be extracted for operation and maintenance of the equipment. It reduces the time required for extracting right and accurate FM information, which will help to respond faster at time of maintenance or breakdown. Both preventive and corrective maintenance requires the generation of work orders. With a BIM model, FM team can remotely check the warranties of faulty equipments and directly generate work orders. Handover to owner or FM team. Handover of the project to building of FM team, a digital handover allows structured handover of design and construction document, which will support building owners for asset operation and maintenance at the project end. BIM can also act as a bridge for different stages of handover processes. The risk of losing asset information earlier created are less. The information generated by the design stage is huge, but it is not tailored to upcoming process. All the building details, equipment details, warranties, geometrical informations are fed into the model, which can be used for the upcoming process. Virtual data can be used for conducting trainings for personalists. Technologies like virtual reality and BIM model, like said by Adesh, can be used to train new hires or FM team handover by extracting the rich data fed into the model.
Hello. Hello.
So you're there?
Yeah. There was some technical glitch which happened. So sorry for that. And I'll just continue with where Abhay had stopped in. So as you were stating that the renovation also, whenever there's a project renovation happening, so we can use the BIM data for the as-built data for retrofitting the design or the existing conditions which are there. So I'll just show a short video where we can actually we are able to see how the BIM models can be used for facility management perspective. So this is the actually the office space which you can see where we have scanned it and then created the anchors where you can for each asset you can actually link it and see the model. Means even though the ceilings have been already put in, but you can actually see the MEP models which are there in the building, and then any operations which related to that things you can actually see this. Basically, these anchors are the points where there are main technical assets which were kept in. So same example we can take in for any of the critical facility, whether it might be hospitals, office spaces, or any type of critical facility. So you will be able to see all the data which is actually connected to those families in the model. And this is a kind of a navigator, a robot kind of thing, which actually helps you in navigating within the building. So this is the part of augmented reality service which we offer with our partner from Finland, so which is technology like Random Manager technology which we are using it. So then it is also pulling in the data from the BMS system. So you can see here the Siemens BMS systems which is used, and this is a complete virtual model of the site and also with the real world. So that's all from our side, team. I think if now we are open up for questions. So the attendees, if they have any questions or any clarifications, which based on the things which we have showcased here, so please feel free to ask questions. And also, I think Adesh and Abhay, you can just pop in and answer those queries in your Q&A box.
Well, I think we have one question from Mr. Uday, who has actually spoken, asked about the time consumed for capturing this data set. So I think you guys can, because you guys have done this in real time, you guys can answer this better.
Yeah, so the basically the time required for data capturing depends upon the type of the site, whether it is a small or a big site, what type of facility it is, whether it is an ongoing construction site or already built facility. So typically the time depends on that. But if you see a particular scan point, depending upon the technology which we use, for one scan in a 360-degree view, it takes approximately 4 to 5 minutes to capture almost a million points per second. So this is the typical timing, but again, it depends upon the quality of the scan, whether it is a medium, high, or means low scan suit, and purely depending upon the use case. So whether we are using the model for creation of drawings or we are just using it for navigation. So this is also one of the factor which we can actually take in for consideration. But if the plain straightforward answer would be to take somewhere around 4 to 5 minutes for a particular point.
So Mr. Uday has actually added to the question the project size, assuming 40,000 square feet, with an ongoing project would take how much time? So if it's a
So I
typical,
think for the
yeah.
for if there's a specific questions, I think we can answer it later. So we do have contact details of Uday, so we'll get in touch with them and see how the things can be taken forward.
Great.
So if there are any other questions, I think we can answer. Or I think Mr. Krishnan has asked about training and modeling. So I think we do provide training on how our clients can actually use these models. How these clients can actually use the model. So we do provide for that. And modeling, so we would recommend that it is under a tight control of activities, because if anybody and everybody starts editing the model or changing the things, so it can actually have a larger impact. But if an owner or a client wants to see the model, so we definitely, whenever we are providing the service, we hand over the model with the proper training so that they can navigate within the files. Are these technologies for only fit out projects or can be used for infra projects? Yes, definitely. We are providing these technologies for infra projects as well. So whether it might be a bridge or means a complex road project or a fit out project like an interior fit out project. So we can use it for both. So as Adesh was mentioning, so the scanner has an inbuilt capability of connecting to any GNSS servers possible, and also we can actually geo coordinate or geo reference the models with respect to the BIM models and the scan data. So the basic difference between these kind of technology application in the real world is when we are talking about fit out projects, so we only talk about the modeling within the confined space inside the building. But when it is actually going outside the building, so we need GNSS and other technologies where we can reference it. What is the accuracy achievable? I think this question I leave to Adesh, if you can answer.
Yeah, so when we talk about georeferencing, if I am georeferencing this on the side, then in that case, the accuracy would be what my control point accuracy is. So we will be maintaining that accuracy. Whereas if I am georeferencing later on, or I'm using some other means of, like, say, cloud-to-cloud registration for connecting the clouds and maintaining the accuracy, we talk about the laser scanner in its own self is 4 mm accurate up to a distance of 50 meters. Right now, that 4 mm is basically the laser dot size. When we say that the laser basically exists from a scanner, the exit diameter is 4 mm. Now you are basically maintaining that 4 mm all along. But this is not a single point accuracy that you talk about. We talk about in absolute terms. When we say absolute, that means from point A to B, you have an accuracy. But when you have multiple points all along the line from A to B, you are basically talking about surface accuracy. And that surface accuracy is within 2 mm. So when we say accuracy, this is what we talk about from a typical floor standpoint. Using it onto an infra project, like I'm doing this in the outdoors, I'm using it on a linear road surface. It is all dependent on the GCP, that is a ground control point. How accurate is my control point? And if my control point is accurate enough, say to the tune of 4 mm, 6 mm, I can actually maintain that accuracy. Is that what the answer would be? Yeah.
Yeah, so the scanning data and BIM data together, I think there was another question which came up, like, can we take the scanning data and BIM data together during operation stage? Absolutely, yes. So if you can actually scan and update your BIM data as per your construction, as per your construction updates which are happened. But if it is already constructed project, then I think we should we can actually take the scan data, convert it into the BIM model, and then take it to the operation stage. Yes, so we can take the both data during the operation stage. So why scan data and BIM data both is needed is because the scan data does not have the intelligence or the properties with respect to the elements which are there. They are just the mesh or the points which are actually created by throwing millions of laser beams. But whereas the BIM model will contain the object related parameters which you can actually use it for your operation stage. So it is recommended that once you scan the data, whether it might be during the construction or after the construction, you actually link it to the BIM model so that you will have some object related associative with the scan data. I think I hope we have answered all the questions. By this, I think we want to thank all the attendees who took out their precious times and attended the sessions and be part of this basically knowledge sharing sessions which we conduct every month. So we have an initiative of conducting these sessions every month, and yeah, so we would like to have you guys in the next session as well. So we'll get soon email communications regarding that. And thanks for attending today's sessions. And we we would like to have your feedback and comments on the topics which you are discussing. And if you have any further information which you want to gather about the service offerings or the technology, so you can get in touch with us. Thank you, Adesh. Thank you, Abhay.
Thank you, everyone. Thanks a lot.